Rationalize the denominator. In today's lesson, we will be looking at rationalizing the denominator when looking at surds. So let's have a little bit of a recap about surds. So a surd is any number that contains a square root sign. So for example, we can have square root 12. We can have square root at 54. We can have 3 root 2. We can have 5 plus the square root of 42, and so on. So these are all numbers with a square root, and therefore these are known as surds. Okay, right. So let's have a look at rationalizing the denominator and what that actually means. So let's have a look at our example first. So number 1. Let's say we've got 5 over square root 2. Now, rationalizing a surd means getting rid of the square root or the surd from our fraction. Okay, so that's what it's called, rationalizing the denominator. The denominator is the bottom number in a fraction, and we want to rationalize this. We want to get rid of the square root, so we've got a whole number at the bottom. Okay, so in order to do that, what we do is the square root at the bottom of my fraction is square root of 2. So what I do is I'm going to times top and bottom. I'm going to do that in a different colour pen. Times by square root 2. And you'll see what happens when I do that. Now, 5 times the square root of 2 is 5 root 2. Okay. And square root times square root of 2 is square root of 4. However, we can simplify this because 5 root 2 stays the same, but the square root of 4 is actually 2. And we can't cancel anything down here because there's no number that we can divide 5 and 2 by. So that's it. We have rationalized our denominator. The bottom number is a whole number and it's not a surd anymore. Let's have a look at a different example. Okay, example number 2. 12 over square root 5. So again, we've got square root 5 at the bottom. That's a surd. We want to make it into a whole number. So because we've got square root 5 at the bottom, we're going to times top and bottom by square root 5. And what will happen there is it'll eliminate our surd. It'll get rid of it for us. So 12 times root 5 is just 12 root 5. And then we've got root 5 times root 5. So remember, you times the numbers at the bottom together. So 5 times 5 is 25. So that's going to be the square root of 25. However, always look to see if you can simplify your fraction. At the top, we've got 12 root 5. I can't simplify that because, well, there's no number that times together to make 5, which is a square number, so that stays as it is. But the square root of 25 is 5. Again, we can't cancel this any further because there's no number that can, well, no common number that we can divide 12 and 5 by, so there is our answer. We have rationalized the denominator. We've got rid of the square root at the bottom, and we've now ended up with a whole number. Okay. So our first example and our second example were very similar. We've just got a square root at the bottom. Let's have a look at slightly different examples to see what we would do in those situations. Now, how about if we had something like 8 over 3 root 2? Now, if you look at question 1, our surd was square root 2, so we times top and bottom by square root 2. Our second example, the square root or the surd was 5, so we times top and bottom by square root 5. In this situation, we've got 3 root 2. Now, this is what you do. We don't times top and bottom by 3 root 2. We need to times top and bottom by just root 2, and you'll see why in a minute. So 8 times root 2 is just 8 root 2. Now, the bottom here, you times the square roots together. So square root 2 times square root 2 is just square root 4. Well, the number in front of the square root 2, the invisible number, is 1. So we times the outside numbers together. So 3 times 1 is 3. Okay, now the top stays the same. We can't simplify that any further because we can't simplify square root of 2. But square root of 4 is actually 2. So that becomes 3 times 2, which is 6. Then again, we can simplify this fraction because there is a common number that I can divide 8 and 6 by. I can divide them by 2, can't I? So if I divide 8 by 2, I end up with 4. And then square root 2 stays the same. And I can divide the 6 by 2, which is 3. Now, we can't divide, we never, ever, ever divide the square root by the same number because just as if I just do it in red, a bit of a star here, if this was 8x divided by 6, we would half the 8 and the 6, that would become 4x over 3. It's similar concept, okay? So we never ever divide the square roots, that's different, okay? So treat it as an x if that helps you make more sense of that, but otherwise we don't divide the square root by anything. So as you can see, when you have a square root at the bottom and you are rationalizing your denominator, you times the top and bottom by that surd. So for example, the example number 1, our denominator that we were trying to get rid of was square root 2, so we times top and bottom by square root 2. The second example, the denominator was square root 5, so we times top and bottom by square root 5. And for number 3, the denominator we were trying to get rid of was square root 2, so you times top and bottom by square root 2. However, this all changes when you have something like this. So example number 4. We have square root of 2 plus 1 all over square root of 2 plus 2. Now, we need to rationalize our denominator, okay? At the bottom, we don't want a square root. When you have a situation like this where you have square root 2 square root plus something or square root minus something, that's all one thing. So when you have something that's plus or minus, that's actually joined to the surd. It's just like we have x plus 1, that would be together. They're together, okay? They're joined together. You can think of it as a married couple. They have to go together. Okay, so what you could do is, if you wanted to, you could put brackets around that because they are one thing. Sometimes they'll put a bracket around for you, sometimes they don't, but if they don't, you put one in just to, you know, so you can, it jogs your memory that they are together. So this is what you do. We are trying to get rid of this bottom square root 2 and plus 2, obviously, because they're joined together. I can't just eliminate the square root 2. So what you do is when you have a situation like this, you times top and bottom by exactly the same thing, but you change the sign. So instead of plus 2, I'm going to do minus 2 and do exactly the same at the bottom. Okay, and you'll see why in a minute. So the top here becomes, well, I'm going to write it like this, it becomes a double bracket. So we've got square root 2 plus 1, and if I'm timesing it by that, that's what it becomes. Remember, timesing, it's 2 brackets together. And the bottom is square root 2 plus 2 and square root 2 minus 2. Okay, right, so let's expand this out, okay? Right, well, the first one here, we've got square root 2 times square root 2, which is square root 4. Then square root 2 times minus 2, that's minus 2 root 2. I've got 1 times root 2, that's plus root 2. And then 1 times minus 2, which is minus 2. Okay. Oh, let's do that in a different colour so we don't get mixed up. Square root 2 times square root 2 is square root 4. Square root 2 times minus 2 is minus 2 root 2. 2 times root 2 is plus 2 root 2, because we've got the positive there. And 2 times minus 2 is minus 4. Right, what we need to do is we need to simplify this now. So square root of 4 is just 2. We've got minus 2 root 2, add another root 2. That becomes minus 1 root 2. We can write the 1 down if you want to, you don't have to. And then we've got minus 2. Okay. Here at the bottom, square root of 4 is 2. Then minus 2 root 2, add another 2 root 2. Well, they cancel each other out. And then minus 4. Okay. Now you could think of this as minus 2x plus 2x if you wanted to. And you could think of that as minus 2x plus x. Okay, that would be minus 1x. And you can see we've got minus 1 root 2. And that'd be nothing. So that cancels. Okay, so you can substitute an x in at the side of your working out if you're stuck, so it helps you out. Okay, so then here, if we move on, we've got whole numbers. We've got 2 take away 2, which is nothing, so we're just left with -1 root 2, and 2 take away 4 is -2. Okay, and that is our answer. However, we can do something. The 2 minuses cancel each other out, so we end up with root 2 over 2. I could put the 1 in front, but we don't need to do that, so that is our answer. Okay. Right, let's have a look at a few of the examples like this. I think it's nice if we have a look at another example that's similar to this. So 4, let's do another example. So I'm going to do 5 over square root 7 minus 2. Okay, remember, anything with a minus or a plus are together, so I'm going to put a bracket around that straight away so I know they're together. I need to get rid of that square root 7. So I times top and bottom by exactly the same thing, but I change the sign, so plus 2. Okay, well, 5 times that bracket is just a single bracket, so 5 times root 7 plus 2. And the bottom's going to become a double bracket. Okay. Okay, so let's time this out. So top one's nice and simple and straightforward. 5 times root 7 is 5 root 7, and 5 times 2 is 10. Okay, the next one, root 7 times root 7 is root 49. Root 7 times 2 is plus 2 root 7. Minus 2 times root 7 is minus 2 root 7. And then we've got minus 2 times 2, which is minus 4. Okay. So let's simplify this. We can't add them together because the 10 doesn't have a square root 7 with it, so that stays as it is. 5 root 7 plus 10. Next to the bottom, square root of 49 is 7. Plus 2 root 7 minus 2 root 7 cancel. Just got the takeaway 4, which we can simplify. So remember, again, we can't do anything with the top because it doesn't have a square root 7. 7 take away 4 is 3. We can't cancel this down because there's no number that we can divide the 5, the 10, and the 3 by. No common number, so it stays as it is, and that is our answer. Okay. Slightly different one this time. Let's have a look at another example. Example number 5. Okay, so let's do now square root of 3, and then at the bottom we're going to have square root of 3 minus the square root of 2. Okay, so again, we've got a minus at the bottom, so that's all together. So I'm going to put a bracket around that straight away. So we want to get rid of the surds at the bottom, so we times the top and bottom by exactly the same thing, but you change the sign, so the minus becomes a plus. Okay, so the top one's just a single bracket, so that's going to be square root 3 times square root 3 plus square root 2. The bottom's a double bracket, so square root 3 minus the square root of 2, square root of 3 plus the square root of 2. Okay, top one's a single bracket, so square root of 3 times square root of 3 is square root of 9. Square root of 3 times the square root of 2 is square root of 6. Okay. The bottom now, so square root of 3 times square root of 3 is square root 9. Square root of 3 times square root 2 is plus root 6. Minus root 2 times root 3 is minus root 6. And then minus root 2 times root 2 is minus root 4. Okay, let's sort this out. Well, I know I can simplify square root of 9 straight away, which is 3. I know I can simplify square root of 6 as well. Actually, can I? I can't, can I? For a minute I thought I could, but I can't because there's no square number that goes into 6. So that's going to stay the same. The bottom, well, square root of 9 is 3, but root 6 minus root 6 cancel. So I'm left with minus root 4, but root 4 is 2. So again, the top stays the same. And 3 take away 2 is 1. Well, do I need to write a divide by 1? I don't, do I? So my answer is just going to be 3 plus root 6. Okay, I hope that was useful. Right, okay, let's have a look at another example then, just to see what other types of examples or questions you can end up with in your GCSEs. Okay, so just going to zoom out there. We've looked at a few different types of questions. Let's do an exam style question now, just to show you what you could be asked in the exam. Okay, you could be asked to answer something like this. Show that 12 over square root of 8 is equal to 3 root 2. Now, the examiner may not ask you to rationalize the denominator. Sometimes this will be hidden in exam question. Now you can see it says show that 12 over the square root 8 or root 8 equals 3 root 2. Well, if that equals 3 root 2, you can see that the answer that they want doesn't have a denominator with a SURD. So they're hinting to you that they want you to rationalize the denominator. So let's rationalize the denominator and see, do we end up with that? So we've got 12 root 8. So remember what we need to do. We want to get rid of root 8. There's no plus or minus with it. So it's quite straightforward. We're going to times top and bottom by square root 8. 12 times root 8 is just 12 root 8. And root 8 times root 8 is root 64. Right, just going to zoom out so you can see the divisional question at the same time. We can simplify this because square root of 8 becomes square root of 4 times square root of 2. Square root of 4, or 4 is a square number. And square root of 64 is just 8. Well, this here now becomes 12 times, well, the square root of 4 is 2 times root 2 all over 8. So again, 12 times 2 is 24 root 2 all over 8. Now, we can simplify this, can't we? What can we divide 24 and 8 by? So we end up with a whole number. Well, I know that 24 is actually in the 8 times table, isn't it? Because I can divide them both by 8. So 24 divided by 8 is 3 root 2. Remember, we don't divide the roots with the number. And 8 divided by 8 is 1. So we divide them both by 8. Do we write the 1 underneath? No, we don't. So we end up with 3 root 2. And remember, looking back at the question, if I zoom out, the question was show that 12 root 8 is equal to 3 root 2. And we have done that. Okay. So the examiner might not ask you to show or rationalize the denominator. It might ask you a question in a hidden form. Okay. Right, let's have a look at one last exam question. Okay, so you might end up with something like this. Show that square root 3 plus the square root of 27 all over the square root of 2 can be expressed in the form square root k, where k is an integer. State the value for k. Okay, so again, they haven't asked you to rationalize the denominator, but they're actually meaning to say rationalize the denominator because they're saying that show that square root 3 plus square root of 27 all over square root 2 can be expressed in the form square root k. Well, that doesn't have it's not a fraction, is it? And the fraction doesn't have a denominator with a square root in it. So they're implying, or they're asking you indirectly to rationalize a SURD. So let's do that. We have got square root 3 plus square root 27 all over square root 2. So let's just rationalize the denominator like we would. We've just got square root 2 at the bottom, so we just times top and bottom by square root 2. Well, remember the thing at the top has a plus with it, so that's all one thing. So let's put a bracket around that so we know that's one thing. That's going to be a single bracket. I'm just going to write the square root at the start because that makes sense, doesn't it, when we're timesing a single bracket out. So we're timesing them together, and then square root 2 times square root 2 is square root 4. So let's quickly time this out. Well, square root 2 times square root 3 is square root 6. Then square root 2 times square root 27, well, 2 times 27 is 54. All over, well, the square root of 4 is 2. Let's see what we can simplify. Can I simplify square root 6? No. Can I simplify the square root of 54? Well, what we need is we need a square number that goes into 54. So let's have a look at the square numbers. Oh, 9. 9 goes into 54, doesn't it? So we can have square root of 9 times square root of 6 all over 2. Well, we've got square root of 6, but the square root of 9 is 3, so that becomes plus 3 root 6. And then we've got all over 2. Oops, rightio. Now, root 6 plus 3 root 6, that's like 1 root 6 plus 3 root 6 is 4 root 6 all over 2. Now, can we divide the 4 and the 2 by anything? Yes, we can. We can divide them both by 2. So if we divide them both by 2, that becomes 2 root 6 over 1. Do we write that over 1? No, we don't. We just end up with 2 root 6. Okay. Now, it says can be expressed in the form square root k, where k is an integer. So state the value of k. Let's have a look. And we've got our value, which is 2 root 6. Now, a little bit of a tricky question here. They're asking for your answer as just square root k. Our answer, as you can see here, when we rationalized it, we end up with 2 root 6. They don't actually have a number here in front of the root k. So what we need to do is we need to put this number 2 back in there. So we've just got basically a SURD. So remember the number 2 is because we've got root 6 plus 3 root 6, which is 4 root 6, isn't it? So I'm going to put the 4 back in there. So we've got root 6 times 4. So if the 4 goes back in, we're sorted. So 6 times 4 is square root of 24, and there you are. Okay. Now, if they've said to you it's in the form, I don't know, something, let's say a root k, then you could leave your answer as 2 root 6. But because they're just saying the answer is in the form of just root k, they want to know what k is. There's no number out in front. So I've just put the 4 back in to the square root. So we ended up with 4 times 6, which is 24. I hope that was useful. Thank you for watching.